Today we will going to discuss about the next part in the wire antenna. Already we have seen the infinitesimal type of the antenna, small dipole type of the antenna, as well as the finite type of the antenna. That part we will going to discuss in the previous lecture, as well as its mathematical equation, how to design of an antenna. That part is also seen in previous lecture. Now, today we will going to discuss about the next part here. I hope that the screen is visible to you. If any problem regarding for visualization as well as for the voice, you please let me know. Okay. Now, here, if any doubts regarding for the point, then you just message on the chat box as well as you directly unmute your mic. The infinitesimal dipole type of the antenna and small dipole antenna and finite length dipole antenna, up to this part we will going to discuss in previous lecture. So we move towards the next point today onwards. Here, okay, up to this point we will learn in the previous lecture. Now this time there is a distribution. I assume that the center feed and the current vanishes at the end point at the impedance value, and that impedance value which is equal to plus minus L by 2. We have seen for the experimentally, it has been verified that the current is at the center feed wire antenna and has sinusoidal form the null at the end point. So for the different length, the current distribution is as shown in figure, and that current distribution is basically depends upon the length of an antenna. Okay, then this length of the antenna should be very less than the lambda, and this value of the lambda, again the value, this value of the lambda, it will be depends upon the operating frequency f. It will be depends upon the operating frequency f, because in case of the operating frequency f, we know that the basic equation c, which is equal to f lambda. Okay, c which is equal to f into lambda. So that what we do here, based upon the c is a constant, basically 3 into 10 raised to 8 meter per second, and f is the operating frequency. That's why the lambda will be calculated. There is a lambda which is equal to c upon f. Okay, c upon f. Then basically in case of the finite length dipole type of the antenna, in dipole type of the antenna, we seen there already there, the voltage is a maximum, means the voltage is the maximum till at the end of the dipole, means the here. Okay, means for this end the voltage is the maximum and the current is the zero or minimum. Okay, then once the time is goes on the increases, the value of the voltage is going to be decreases, means up to the here the value of the voltage is going to be decreases and the current value is goes on the increases. And at the center axis, for that center axis, the current is a maximum, the value of the I is the maximum. Okay, here is the value of the current is the maximum, and the value of the voltage which is equal to zero, which is equal to zero. For this question, how the wave is generated, we see here. Just I have to be share the whiteboard to you. And here, for this case, what happens? How the wave is generated, and that type of the wave is called as the smoky wave, which is called as the smoky wave. Okay, then see. then we have seen that how that wave is generated. That part we have seen here. This is the small dipole type of the antenna. Here is the small dipole type of the antenna. Here is the central axis. Okay. Here is the central axis. And from that central axis, whatever we have to be able to measure the length of the antenna of including these two parts. Okay. Which is called as the length of an antenna. And this length of the antenna may be the lambda by 2, lambda by 4 in this way. Here. Okay. Then till at this end, the voltage is maximum. Means there are the dipole antenna. This is called as the dipole antenna, and di means 2. There are the 2 poles. Okay, there are the 2 poles. Here is the first pole and here is the second pole. That's why we called it is the dipole antenna. So here is the voltage is the maximum. Till at the end is the voltage is the maximum. Means here is the plus or minus. So here is the charge is generated till at the end of the dipole of an antenna. Means here is the positive charge and here is the negative charge. Okay, there are the 2 charge will be generated, positive charge as well as the negative charge. Once the time parameter is goes on the increases, means when this signal is radiated, once the signal is radiated at the t which is equal to 0. Okay. Then there are the 2 parameters should be varying with respect to this. The first parameter is that the voltage. Here is the voltage. And the second parameter is the current. Here. Means there are the 2 parameters should be generated, either voltage and current. At this stage, when t which is equal to 0, the voltage is maximum. Means here is the voltage V which is equal to V max. Means here is the T which is equal to V max. And the current I which is equal to 0. Okay, here current I which is equal to 0. So this time parameter, the time parameter T is goes on the increases. It's suppose 1 by 2T. 1 by 2T. Means the total time duration. Means t which is equal to 1 by 2t. For that instant, what happens here? The current value should be goes on the increases. Means the current value, that current value is goes on the increases till at the central axis of an antenna. And it will be increases till at this point here, this point, the value of the current I which is equal to I max. Value of the current I which is equal to I max, and the value of the voltage V which is equal to 0. V which is equal to 0. Okay, means for this case the current is a maximum and the voltage is the 0. Then what happens for that instant here? For this case, the charge is also moving. Means this is the cases to increase the current value as well as to decrease the voltage value. Okay, means for this instant, what we see, the value of the current is goes on the increases here. And for this case, the voltage is the maximum till this end at t which is equal to 0 here. And the value of the voltage is goes on the decreases. Okay, means one parameter is goes on the increases, another parameter is goes on the decreases. And this is a purposefully we do here. Because of that the wave should be generated. Okay, so that how the wave is generated, see, here is the positive charge and here is the negative charge till at the t which is equal to 0. For this case, t which is equal to 0. Once the time parameter t is goes on the increases here to increase, then this positive charge and this negative charge will become closer together. It will be come closer together here. If this positive and negative charge, these two are come closer together, and once for this axis here, the positive charge, number of the positive charges and number of the negative charges are overlapped together. Means this will become into this direction and positive charge will become into the opposite direction. Okay. So during that process, what happens? During that process here, positive and negative charge, the most of the positive and negative charge will be clubbed together, overlap together. So what is the resultant? The resultant is that 0. Okay. So here is the 0 field should be generated. And apart from that, the remaining positive charge and remaining negative charge, that will be come to the here. Okay. Means the remaining negative charge will be moved at the opposite direction in this way. And the positive charge will be come to the opposite direction. Means this will be moved at the opposite direction. And for the next situation, what happens? For this case, the wave should be detached together. How the wave is detaching? See, wave will be detached together in this way. The wave will be detached together and it will be separated from the antenna and move towards the reception side of the antenna, towards the here. Okay, so that the shape about the antenna is just look like this. Here is the antenna. This antenna will be placed along the x and y axis. These are the two ends. And once the wave should be generated, that wave, the first wave, will be look like this. Here, the first wave. Means this wave is a detaching from an antenna. The first wave is a detaching from an antenna. Then second wave is a detaching from an antenna, just like this. And this type of the shape of an antenna, which is called as the smoky type of the antenna, which is called as the smoky wave type of the antenna. And once these charges will be, see, at a one instant, what happens? The charge will become closer together, and another instant, the charge is moved away from each other, so that there is a movement of the charges, the wave is generated, which is called as the smoky type of the wave. Okay, means here the smoky type of the wave is generated. Means actually the process should happen to the here. Beyond here is that the smoky. This type of the whole process should happen. That all the process should happen from the here, and then only this type of the distribution is happen. Okay, whatever this positive and positive charges will be shown at the opposite side. Its meaning about that, just to vibrating the charges, it will become closer together or away from each other, then the wave is generated. So the length of the antenna is very important, and here is the triangular current distribution is given. Here is the circular current distribution is given, when the length of the antenna L, which is equal to lambda by 2. Okay. Yes, all of you understand? Yes, all of you understand? Chaitali?
Sir, आवाज
Yes, yes, sir.
Yes?
Yes, sir.
Yes, any doubts you please ask me. My voice is audible, everybody?
Yes, sir.
Okay. So here, this distribution, then the T which is equal to lambda by 2, and here is the L which is equal to lambda by 2 by lambda. Once the this value is the goes on the increases, this value is the goes on the increases there, then here may be possible to current distribution value is going to be changed, so that the value of the L is the greater than lambda or less than 3 lambda by 2. In this way, it will be to change the variation, to change the variation about that. Then here is the radiation pattern. For that radiation pattern here,
Yes,
Yes,
sir.
sir. Audible.
No, sir.